to the science 25, experiment number 1. So before you come to the lab, make sure you have the lab manual with you. This experiment is about the matrix system, density and temperature. So first, we need for the matrix system is a ruler. We also need for density experiment, we need a graduated cylinder. For the density experiment, we are also using the centrogram balance. And for the temperature, obviously we need a thermometer. Okay, so for the first experiment, before you come to the lab, make sure you read your lab manual because we don't want anyone go lost when they do the lab. So at least you have some knowledge before you come to the lab. So first procedure, it says that measure and record your height using a meter stick. So here we are using a meter stick. So what we are going to do, it says that take your height. I'm trying to get a mark here. So here we will use our scales. Which one is in inches? So let me see what it comes here. It's about 62.5. You can see. You should be, when you take the measure, you should be on eye level so that you can see. So it's 62.8. So that's why we always have to think when you take the measurement, it should be on eye level. Otherwise, you can see from the down and you can get a wrong data. So always you have to be on eye level so that you can see the measurement. So I can see now it's a 62.8. So 62.8. This is in inches. Okay. So this is my height. Alright. For the second one, it says measure cubit, measure the distance from elbow to the tip of the middle finger. I will show you later how to convert from inches to centimeter to meter. First, we will get the data. This is our experiment, so we don't want to waste our time. First, we get the data, and then we have time to finish our lab. So suppose there is a black thing, so I can put it here from 0. So I put this 0. Okay? So 0 to middle finger, so elbow, middle finger, still. So it's 15.6. 15.6 inches. This ruler is in inches, so 15.6 inches. The next one is the distance from the end of the nose to the tip of the right thumb. Okay. It says that from my nose to tip of the right thumb. Tip of the right thumb. nose to tip of the rectangle. Make sure it's straight. So its thumbs, you can see 71. So this ruler actually is centimeter. So 71 centimeter. Alright. So now we can do the conversion of unit. So this is number 1, this is number 2, and this one number 3. Okay, so when we do the unit conversion, we can use our unit information. So from this table, we can easily get do from any unit to other unit conversion. So number 1 is 62.8 inches. So 62.8 inches. We are trying to find out in centimeter and also in meter. Okay. So we know that as I have inches, I need to go to centimeter and meter. We will try to find out the relationship with inches and centimeter. So from the table, we know that 1 inches is 2.54 centimeter. So from there, inches and inches will be cancelled. So we will find our answer in centimeter. So remember, on the top, whatever the number is, we can multiply. So this part we can multiply divided by the bottom part. So that's how it's easy to find out our unit conversion, and you will never ever get the wrong answer, because if you try to cancel any unit, it should be on the opposite side. Inches. So we can get the desired unit on the top. So 62.8 times 2.54, which gives me 159.512 in centimeters. Okay. Here, I took my data in 3 sig figure. Okay. So my answer should be in a 3 sig figure too. So 159.5, right? So if it is anything after, if I want to get the 3 sig figure, so 159, as it is 5 or more, we will round it off. So it should be 160. If it is like 159.4, my answer would be 159. But as it is 0.5, so 5 and more, we can round it out to get my 3 sig figure. So my answer would be 160. The second one is, when I go to the second part, do not use this rounded number. You have to use this number. So 159.512, because this is not the actual one, okay? This should be the actual one after doing all the measurement. So this is the rounded amount we want to do. We want to get the 3 sig figure as we get the data. So 159.512 centimeter. The same thing, I want to cancel my centimeter and I want my answer to be meter. So 100 centimeter, 1 meter. So times. So come to the second part, which one is we are trying to find out the density of metal. Okay. First, we need a graduated cylinder. This is called a graduated cylinder. You can find out in your lab 10 milliliter graduated cylinder, 100 milliliter graduated cylinder, any of them. So it depends on which one you're using. You have to use some general knowledge, like which one will go inside. Like here, I'm going to use the copper. If I use the 10 milliliter graduated cylinder, I cannot drop it inside. So just common sense. Okay, so this is 10 milliliter graduated cylinder. So we are going to get the volume of water. I mean any liquid. We have to know how we will get the volume of liquid. When you read, here is 100 till 100, there is a reading it, right? So we have to know the meniscus curve where we can read the graduated cylinder. If I can see, I have liquid in here. Remember, when you read anything, it should be an eye level so that you can get the correct data. Okay, so when I read it in here, I can see the meniscus curve, which one says that 39 in volume, 39 milliliter. So if you can see, if you can see that, so this one is 39 milliliter. Okay. So first part it says volume of graduated cylinder plus water. So I get this one. Number 8 says volume. There is only graduated cylinder plus water, which is 39 milliliter. Second part, volume is a graduated cylinder plus water and plus my copper cylinder. Let's see. When you drop any metal in a glassware, make sure you don't drop it like suddenly, because the glassware is a very it can break down, right? It's a very thin glass. So when you put inside in any metal, you should slide it so that it doesn't break. So copper. I'm getting some bubble here, which I don't want. Okay. So now my in eye level, I can see $40, $41. I can say 41.9. Actually 42. See 42. You can check the meniscus curve. It comes 42. Each mark is a 1. So 40, 41, 42. So 42 milliliter. So volume of copper cylinder. Let me see. Volume of copper cylinder, which one is basically, so this whole number is graduated cylinder plus water. The third one is second one is graduated cylinder, water plus copper cylinder. So if I cancel my graduated cylinder and water, so I can get my copper cylinder volume, right? So 2 minus 39, which will give me 3 milliliter. So volume of copper cylinder is 3 milliliter. That's all I will check. My volume of copper. Okay. So now I'm trying to find out the mass of the copper cylinder. So we know the density formula. Which one is density equal mass over volume. This is mass over volume. I know the density of the copper. The density of the copper is 8.96 gram per milliliter. So I know my density. I know the volume. This is not. So I can find out my mass. So mass equal G times V. Density is 8.96 gram per milliliter. I'm multiplying, right? So multiplying my volume. Volume is 3 milliliter. So milliliter cancel. I will get my mass in gram. So 8.96. 8.96 times 3 is the 26.88 milligram. Okay. As I'm doing those all the two sig figure, I can round up and I can make it 27. So this after decimal point is 8, which is greater than 5. So 27 gram. Okay. So now move on. Move on to the next part, which one is I'm getting the mass using the different balances. So how? So the thing is, I did the experiment, right? I get the mass of copper, but I'm not sure, like, to make it satisfaction that my desired mass is actually okay or not. So we can use two different balances. One we are going to use the centrogram, and another one is analytical balance. So this is analytical balance. It's easy to use it. You can say this is digital, and this centrogram is analytical. So if it is digital, there is less chance to get the error than the analytical one. And also experiment, sometimes there is a human error, we can get the wrong answer too. Okay, let's do my analytical balance. So I'm doing all the water, because this is water, so that's why I'm putting it inside the sink. If it is hot water, I'm not going to use it. Make sure it's dry, no water. So this copper cylinder, you can see this is already in 0.00. So now I'm putting it here. It's 26.75, almost. Okay, 26.75. Actually, if I don't do round it out my answer, so this is correct. Almost correct. 26.75, right? And the value is 26.75. So if I round up like 26.8, it's almost very close to my experiment. Very close. So now I'm using this with the center point. So there is 2 bar. We can move it forward and here. And also, here is the line. We have to match it to get the exact mass. So this line and this line should be matched so that I can get my actual mass. You see? There is a air here, so that's why we are getting like it's just going up and down. Okay. It's always like going up and down. So anyhow, we can see the 20, this is between 6 and 7. So if I check with the ruler, okay. So if I check with the ruler, I can get 26.7. I can get 26.7. So 0.6. So 20, 26, 65, 67. So 26.67. 26.67 in gram. It is also in gram. This one is my analytical balance or digital balance. And this is the second one. Okay. So you can see the almost they are very close. By experiment I get 26.88. Using the analytical balance is 26.75. Centrogram is pretty hard to get the answer because there is an error and it's just always moving on. And I cannot, it's not stable. So if you have error inside and it's just going up and down, it's hard to get the correct number. So 26.67 as we make it. So almost 26.7. If I do the 3-stick figure, 26.7, this is 26.8, so I can say this is the correct one, the analytical balance one. So there has no other influences or no interruption to get my correct mass. There has no human error, there has no error which can interrupt to get my mass. Okay, so told you guys that analytical balance will give me the more accurate answer because there is no interruption, there is no error, there is no human error, so we can get the correct answer more easily. So that's why you can see in the lab manual it says that the mass obtained from the analytical balance will be your expected mass value for the copper cylinder, so in expected. So I'm using this mass as the accepted one. This is from the analytical balance one. So analyzing data. So percentage of differences on the experiment. Experiment number 1. Which one is the better cylinder? You guys can see this bar. This is called the absolute value. That means doesn't matter after doing the calculation, your answer comes negative, it should be always positive. So this means this. My answer will always be positive. Okay? So this one I'm doing for my graduated cylinder. So graduated cylinder, M expected is the analytical balance. So 26.75. Expected is 26.75 minus the graduated cylinder, which is 26.88. 26.88. Accepted one is 26.75. All are inside the absolute value. Okay. So you can see. Minus 26.88, which actually give me the negative value as I have the absolute value, so I'm not going to use my negative sign. So 0.13 over 26.75. Is very low. These are 4.85 times 10 to the power negative 3. That means it's a negative 3, right? So 0.00485. This is my difference. Let's check for the central. Central gram. First differences. Experiment number 2. The central gram experiment 1. I'm doing the percent differences for experiment number 2. The same way in accepted minus in experiment divided by in accepted. it is 26.75. So I will get 26.75 minus 26.67 divided by 26.75, which gives me 2.9924 negative 3. So let's say 0.000299. So this one is so now we get the differences, percent differences from the center round and also from the graduated cylinder. So from the graduated cylinder, we can see that the number is 0.00485, right? So and center round it is 0.00299. So the differences for center round is less than the graduated cylinder. Obvious, because this is a tool, the measurement tool. It gives me the more accurate than we do by hand in experiment. So this is correct. So after doing the calculation, we get 1.59512. The thing again is, as I told you, on the top part we can multiply, and whatever is found in the bottom part we can divide. So if you have some numbers, multiple numbers at the bottom, so all the numbers will be multiplied. The bottom thing, all the top part, the numbers will be multiplied, so we can divide from the top to bottom. So that's how we can get our answer. So now my answer is 1.59512. We need the 3-sig figure, as my data is 62.8, which is 3-sig figure. So I will get the 3-sig figure. As after 9, my number is 5, my digit is 5. If it is, as I told you, that 5 or more, we will round it up. So we should get 1.60 meter. So this is my 3-sig figure. This is my answer for the fourth one. Now for the second one, 15.6. Inches. It's 1 inch. So I will do the same thing. I will multiply. So 15.6 times 2.54, which comes 39.624. Again, inches cancel and centimeter. My 3-sig figure. Same thing I have to do 3-sig figure. Now, after 6, my digit is 2. So when I try to round up, it will not going to increase. So my digit will be 39.6. When I go to the third part, as I told you, I will use this number. I will use this number for my third calculation. So 39.624 centimeter. 1 meter is 100 centimeter. So I will divide it. Divide 100, which comes 0.39624 centimeter. As I told you, 3-sig figure. Remember, when I get the significant figure, it always start with a digit, not with 0. So here, it will start from here to there. 0 is not counted for significant figure. So I will get my 3 sig figure is 0.396. My 2 is less than 5. So 5 and more I can round up the previous digit. As it is less than 5, so 3.396 in meter. So this is my answer. For third one is 71 centimeter. Okay, so I have to convert it to inches. So I have this in unit. So I have to convert it to inches and in meter. So 71, third one is 71 centimeter. I can easily convert it to meter. So 100 centimeter in 1 meter, which I will just divide. 71 divided by 100 is 0.71 in meter. 2 sig figure. Here also 2 sig figure. So I will do it. 71 centimeter. I'm trying to find out now in inches. So before what I did, I had inches. Whatever the number is, I have inches. So I will do. I did 1 inches in 2.54 centimeter, right? So inches will just cancel. Now I have centimeter. So what I'm doing, I will reverse. So as I'm trying to get my answer in inches, so centimeter I want to cancel. So 2.54 centimeter, and it should be 1 inch. Centimeter cancel. I will get 71 divided by 2.54, which was 27.9527 inches. 2 sig figure, right? 2 sig figure. So my answer will be 2 sig figure. Here, after decimal, I have 9, which is 5 and more. I said that I can round it up. So if I want to 2 sig figure, it should be 28 inches. So this is not 2 sig figure. So the third part of this experiment is taking the temperature. So using Temp.strike record your temperature after 5 minutes period. So this is the thermometer we usually use in lab experiment. This one, you cannot see this type of thermometer at your home, because we are not using it. Okay, so get the temperature. I have to move my gloves, otherwise the rubber is heat resistance. I cannot get the temperature. Alright, so this thermometer is in degrees Celsius, and your lab manual is asking in Fahrenheit. We can easily convert it. That's not a big deal. Get the temperature first. Okay, so after 5 minutes, I can see on my thermometer my temperature is 36.6 degrees Celsius. Okay, so now I'm trying to convert it to degrees Celsius to Fahrenheit. So my given temperature in Fahrenheit, you know the formula. So degree Celsius is 5 divided by 9 Fahrenheit minus 32. So degree Celsius, my one mass in Fahrenheit. Okay. So 9 times degree Celsius. This is 5 degree Fahrenheit. So 9 times my degree Celsius is 36.6 Fahrenheit. So I can move it here. This is minus negative under 60. 5 degree Fahrenheit. I don't have my Fahrenheit. 9 times 36 plus 60. And this 5 is going to 489.4 divided by 5. Which comes 97.88 degree Fahrenheit. If I want to keep my freezing figure, so I can get 97 point, this is 8, right? So it should be 9, 85. So this number is more than